Manufacturing and industrial environments provide their own unique challenges for wireless communications. Harsh conditions, both indoors and out, create a daunting task for engineers to work through. This is where we come to discuss those challenges, share ideas, and help one another out. My name is Scott McNeil, and welcome to the Industrial Wi-Fi Shop. Hello and welcome everyone to another edition of the Industrial Wi-Fi Shop. My name is Scott McNeil. Co-hosting with me and color commentary is Jeremy Baker. How you doing today, Jeremy?
Excellent. It's a beautiful day here.
So I figured, I've always wanted to learn more about radiating cable antenna, radiant cable. There's a bunch of different names for it, but I have never successfully deployed it. I haven't really been on any projects involving it. But as it turns out, fortunately, Jeremy has actually. Jeremy has a number of these kind of deployments under his belt. So he has worked with Radiant Cable quite a bit. So we decided to do a deep dive into this rather interesting subject. What I find fascinating is the fact that, Radiant Cable is actually all over the place, a lot more mainstream than I thought, but it's something you don't really hear about a lot of people discussing unless you go to specific vendor sites where, they discuss it heavily, but they're also trying to sell you cable. So I am really interested to see what Jeremy's got in store for us, deep diving into this subject so that we can all learn a little bit more about Radiant Coax. So what you got for us today, Jeremy?
I guess we could start out at what would be considered like a high level. And so you kind of already asked, but what is radiating cable, or I call it leaky coax or R-Coax? Now digging in, I saw somebody refer to it as like a wire for a wireless system. Kind of digging in on that. Leaky coax is essentially an extruded copper core with an external copper sheath. And then there are specific slits that are put into that outer jacket, which allow RF to escape the matrix. So it's comprised of essentially four components. There's an inner conductor, which is that extruded copper core. And then in some cases, I've seen where they say it'll just be air gapped, but typically it's like a dielectric low density polyethylene or something like that.
So that's like when like almost like a plastic material, right?
Yeah, so just something non-conductive. And then there's an outer protective cover, or there's the outer sheath which has the slots, and then the cable jacketing which kind of holds it all together and then essentially provides some layer of protection either from chemicals or UV or abrasion, which hopefully you're not getting it damaged. And I've got some good examples of that we've seen recently. Uh, and apparently this, it's an older technology too, so it's been deployed for 40 to 50 years from what I can tell. Um, and again, like the slits that are in there, you could look it up and we'll post some pictures in the show notes, but the slits seem kind of like the secret sauce here in that the way that they're put into that outer sheath and then the shape and frequency, it kind of dictates like how you tune the antenna for the RF that you're putting out of it. We've seen, Scott and I kind of listed all the different names that we've seen. So radiant coax, radiating cable, leaky coax, leaky feeder, R-Coax. And then I also put a word that got censored. It says expletive deleted because it's a pain in the butt to work with, sort
You
of.
know, the whole leaky feeder thing, I had never heard that. I had never heard it referred to as that before, but there's entire websites that refer to it as leaky feeder.
Mm-hmm.
And apparently that is a common term in mining,
Yeah,
for this style of antenna. And I was like, well, and that shows you how much mining, I've done. So I'm not one of the seven dwarves.
me neither. Hi ho. Yeah, so then there's your standard boilerplate kind of use cases that always come up. So like an AGV system or like an ASRS type deal, overhead cranes, rotating machinery, skillet systems, which are basically just kind of like a flat platform sled type application that gets pushed along in like auto manufacturing.
For our
Um,
OT guys and wireless guys who are not familiar, what did you say? ASRS, is it what you called it?
Oh yeah, ASRS is so like an automated storage and retrieval system.
Okay. All right. I
Yeah,
just
so
wanted to.
so if anybody's old enough to remember renting a movie from a red box, right? Like you make your selection and then there's a little robot deal that runs in there and then grabs the tape out of a specified slot. So it's kind of like it has like a unique registration for each bay that's in there.
Okay.
Yeah, that's a good call out. It's also, I think I said monorails, and then Scott, previously mentioned mining, which, you've got long, narrow tunnels, and you want to be able to have a consistent connection as you go deep, deep, deep down in there.
And I didn't realize too, until I was researching for this episode, that apparently it's used in airlines and airplanes, and so that radiant cable is run behind the overhead bins, and so that's where your Wi-Fi is coming from on your on when you're flying.
Yeah, that's funny because I always wondered about that, like what kind of antennas they used in there. And I've heard it used in like hotels between floors. Some of the examples I've seen too are like putting like cellular signals in tunnels. So like you're drive under a river or under a bay.
I had heard of it being used with cellular and various other DAS systems to help increase signal within deep within buildings and whatnot. I believe Jim Palmer may actually have had some experience with that, as I recall, when he was on a while back, and he was talking about some of those cabling antenna features and how too much power got put to one, and it was throwing arcs of electricity off the end.
I bet
I'll have
that
to go
was
back and re-listen to that one. That was that was pretty crazy.
yeah, I bet that was radical. But yeah, so like I said, it's kind of a pain to get installed. It's stiff, and it's easy to damage. Not necessarily, if you scrape it or something. I mean, it's like a millimeter of plastic for that outer jacket, but if you overbend it, so if you're not careful, you can damage it. In the Siemens documentation, right, they refer to the RF field as like a spatially limited radio link. So there's a couple components on that, but also in best practice, right? Like you can still see that stuff. Like you're not supposed to repeat like an adjacent channel for this stuff within 30 meters of the cable. And you'll pick it up. Like, I mean, we've been in entertainment rides where it's like you're on one side of the set and then you go 50 feet and you're still picking it up with like an Ekahau tool. And so it can interfere.
What kind of when you're that far away, what are you seeing at
You'll still see
signal strength at it?
you'll still see it like you can still see it potentially like in that case we're seeing it like in the 80s, so it's enough to interfere.
Oh wow, okay.
Yeah, and it's I mean even if you have and we've got some situations with some customers where like even if you've got like a negative 60 signal, um 50 60 stuff that's at negative 85, like it is susceptible to interference because it is CISO.
I
um
didn't even think about that because it is SISO.
if you so that's where you have to be you know this site is outdoors and has some adjacent businesses that have some outdoor Wi-Fi, and then they've got like a point-to-point blasting over the top of them, and I'm pretty sure it jumps channels, so sometimes they'll see that stuff. So there are some mitigation things that you can do, like kind of shielding the client antennas and the coax.
You know, the few applications that I've personally seen were put in place to replace slip rings on rotating equipment.
Yeah,
Um,
yeah. So I got some notes about that too. But yeah, it's definitely like made that well, here's a good one too. So like what's a slip ring?
yeah, that's a great thing. If you're not familiar with what a slip ring is, it's two rings that can rotate but stay in contact, and they pass electrical impulses across so that data can carry across and or power depending upon the slip ring type. The ones that I have seen, they were data slip rings, so they were low voltage. They weren't designed for higher voltage to also pass power. And it was an R-Coax antenna infrastructure put on both sides so that it could take and eliminate the slip ring, because it was constantly causing unplanned downtime on those particular machines that they had.
Yeah. And I think we've done some, I don't know if we have any installed, but we've tested it where it's like using like an R-Coax to R-Coax antenna. So you know, depending on kind of how those
Well,
things
and
are.
these were high speed bottling machines, and so the only thing that could keep up with that would be Wi-Fi with how fast these things are rotating. I thought that was
Hmm.
pretty interesting.
Yeah, for sure. And so, yeah, so exactly like you can replace slip rings and you get that constant flex, you know, the constant flexing of cables. Copper's going to break, fiber's going to break over time because that's just the nature of repetitive stress.
Yeah, and slip
Um,
rings, not that I've spent a lot of time pricing them out, but slip rings aren't cheap, and they're typically not easy to install. You typically have to tear apart a lot to get what all that translates to is prolonged downtime, right?
yeah. Well, I mean, that's exactly it. The, as far as the other concern for that too is this thing, you know, do you keep an extra $70,000 cable on the shelf just in case? Or, you know, it breaks unexpectedly and then you got, you know, this thing's only manufactured across the world in Germany or, you
Right.
know, whatever country, and you have to put your custom order in. They have to build it. And then, you know, depending on their workload or whatever, it might be 2, 3 months before you can even get a replacement in. So a lot of times, um, we'll have customers that look for something like this because then they can just get an off the shelf power cable locally that doesn't have that embedded data component. So yeah, it's very handy and just make somebody else install it for you so you don't have to fight it.
So,
Uh,
what all frequencies can these things be tuned to?
well, so that's the next kind of phase is like discussing the RF propagation. So kind of commercially and like what we've touched is there's ones tuned for 2.4 gigahertz, there's ones tuned for 5 gigahertz. And then I believe I was researching it and there's a new 1.21 gigawatts band that's going to be released in early 2025. So that'll be pretty interesting.
I'm looking forward to that one.
I'm not sure how much I don't think
I've heard that those can be powered by Mr. Fusion, so that'll be interesting.
that's yeah, that's true. And they're rated for 88 miles an hour. So just be on the lookout for that. So if you've got an application that runs that fast, that's a perfect fit.
Awesome.
But you know,
Well,
touching
on a
on,
side note here, for the entertainment aspect that you've deployed these in, was it typically 2.4 or 5 gig?
we don't touch 2.4 unless, I mean, it's
Okay.
just if you can completely, I mean, this is the problem that everybody has, right? Is that it's saturated, and we all know you know, you got the three non-overlapping channels and all the stuff that can interfere people's AirPods and all that stuff. But the problem with that is, I mean, there are customers that do use it, but you have to have your RF environment like completely locked down because you know, interference is, you know, this stuff can be pretty sensitive. So not typically. And you do need to be really careful ordering it that you don't order 2.4 tuned R-Coax and try and run 5 on it, vice versa. And
So that
sometimes,
no that
oh,
that leads me to another question. When you're doing a 5 gig setup on RCoax, um, I know it's CISO for the most part. I guess that depends on the application, but are you using single channel architectures like our 20 megahertz wide channels rather, or do you use wider channels depending on the application and or
uh,
the radio airspace?
it depends. So we'll typically, I mean, you can do like a single channel architecture. So a lot of times it'll be like an IPC. So a lot of times when we see it, it'll be like a Siemens IPCF system. So you'll have like whatever, maybe 3 automation channels, or sometimes you might even only get 2. So usually I know ProSoft typically will do like, uh, and ProSoft guys, please chime in and correct me. Um, but they'll typically deploy it. My understanding is as a single band application, but in like an IPCF or something, you could probably get away with using a single frequency and then just hopping on segment to segment. But you would kind of like space it out, and you would go, um, you know, frequency A, frequency B, back to A, back to B, kind of depending on how it is. And then
And
there's
and this
and
is
then
just because
there's
my brain keeps going to it. when using the different 5 gig channels, do you guys typically use DFS channels or do you avoid DFS channels?
So you usually do try to avoid DFS. I mean, again, it's like how is it deployed? So if you're using like a proprietary protocol, you might need to avoid DFS channels because if there's not like a mechanism for a fallback channel, if you're if you're running safety or something on it, if it's fault tolerant, then you could use a DFS channel. The Siemens stuff isn't like officially rated for that, or
Okay.
it's not tested at that, but it's tuned for like low fives, high fives, so it
Okay.
it works kind of any channel you want. you get obviously you get degradation of signal in that, but you can do it. Nobody can tell me what to do. Nobody puts baby in the corner. Um, but yeah, I mean, that's kind of the nature of some of our stuff, though, is it's like it's a science experiment. So then you say, hey, it's this not necessarily like the off the shelf application of this, but does it work, right? Or maybe it's not necessarily a best practice, but we've been in systems where it's like, a switch isn't supposed to be covered in bird crap for years, but it's still working. Don't touch it.
Right.
Or I always think about that like picture. It's like a picture of a switch sitting in a server room that's got like 15 years of dust on it with a post-it note that says "Do not touch."
Right.
uh, yeah, but so the propagation, it is sort of like directional coming out of the perpendicular to the face of the cable. But I think about it kind of like those perforated garden hoses that you kind of string along your garden, and they've got holes every couple of inches, so like every inch has some water coming out of it.
Oh, yeah,
Um,
a soaker hose. Yeah.
yeah, yeah, that's right. And I don't know how many people know what this is anymore, but I call it like an astropop, like the way that the signal looks. So at the beginning, where you come straight out of the radio into the antenna, that's where you have the greatest power. And as it attenuates down the cable, it starts as a broad cone and then it shrinks down. And
For
so,
for reliable communication on a system like this, what is your preferred like distance from the cable itself for your end devices?
okay, well, so there's like a couple of things and that happen here is that it has like a near field and then it has a far field. And so the near field is like 2 to 10 centimeters from the cable. If you get in there, you're in kind of the strongest field for the cable. And then there's some best practices for like not putting your antenna perpendicular. You want to give it a little bit of an angle. And then, but I mean, in testing, we've gotten, 40 feet from it, still talking to it sometimes. And so it's kind of the mystery where it's like you read the documentation, you're like, I've got to stay, exactly within 2 inches from this thing. And that's not necessarily the case. And one of the things I said, it's like if you're standing there and you can like reach out and touch the cable, like anywhere from that distance from your shoulder to the antenna, if you can get in there, you should be able to get a good signal to it. So it's a little bit more forgiving than it seems on the face.
Yeah, reading through documentation, it seems like pretty restrictive, but if you in the in a real world deployment, you actually have, a foot or two of leeway to where you're going to have a reliable connection. That seems a whole lot more doable.
Yeah, and we've tried all kinds of stuff like putting an omnidirectional antenna off the end of the cable to see if we can like extend or like catch a jump in a maintenance bay and really like it'll stay. We've got jumps of like 15 feet in some of the attractions that we have for like a maintenance bay where they'll pull a vehicle off of a ride and it still stays connected over that. There's an outdoor application that we have where it was like staying on a segment that was like 20 feet away and you're on the new segment with a stronger signal. And so it's still able to sustain communications over that.
So you
And so
mentioned um safety. Is safety primarily what you run over these systems?
it depends, but I mean, yeah, usually it's like SIP or something like that.
Okay, and for those not familiar, SIP is actually CIP, and that's shorthand for Common Industrial Protocol, which a lot of safety equipment uses as a communication protocol.
Yeah. So is that kind of like like an open, not like open source, but it's like an open standard?
I don't know if it's.
Or is that
I think that's
proprietary
an
for like
I think
Rockwell?
SIP is. I'm not sure. I have to look it up. I want to say SIP is IEEE. I could be wrong.
Yeah. I just know that sometimes that you have to, so in some of these systems, so this as like a little side quest here, usually like on the wireless side, we'll have to adjust like the QoS settings in the radios to make sure that that stays at like the highest priority for traffic that's going across it. So that's fun figuring that out. And then just kind of while we're still on the signal propagation side, the far field is like 0 to 3 meters approximately. So you can talk to it a ways away. And then as you install it, um, you don't always have to do this, but usually like you want to have like the head end of your segment going into the tail end and then the next segment starting at the head end. So you get that stronger signal. So you kind of entice the radio to roam a little bit earlier to it as soon as it gets a good signal.
So,
Um,
as a quick follow up, SIP is not an IEEE standard, but apparently it is compliant with IEEE 1588 standards,
okay.
which is for PTP, Precision Time Protocol. So, any of your network guys out there, I'm sure you're more than painfully familiar with PTP.
And hopefully nobody's screaming internally that I butchered that. So yeah, so then we can, I guess we can kind of talk about like the installation part of that too. So like as a physical feature on most of these cables, there's a ridge that they put on the opposite side of the outer shield where the slits are manufactured. And so that kind of gives you like a physical alignment ability. So that way, I mean, you can kind of see like it's almost like it's vacuum sealed or like however the coating's applied. You can see the slits in the cable, but this way you can kind of physically feel for that ridge. So your transmission surface is exactly on the opposite side of the cable from that ridge. So as you install it, and that's kind of you as you're walking along it, you just run your finger and feel it if it's in or out of alignment. So yeah, make sure your antenna's on the side that the magic RF comes out, or you're going to have a bad day. And then another thing, you don't mount it directly to a surface. You make sure that it's standing off by at least 5 centimeters. They have plastic clips that can be mounted on the end of like a threaded rod, or they've got like special standoffs. And so we've done some like creative unistrut connections and then like varying lengths of M6 to like fit curves and stuff. So I mean, there's all sorts of ways to do it, but it's just like an M6 threaded rod that you can put in there.
Yeah, I would
Um,
imagine like any other sort of antenna, if you have it, plastered up against a solid dense surface, it's going to warp the radiation signature of that frequency, whatever it's tuned to.
mhm.
So I could
And
definitely
then
understand the standoff that you need to have for that when you install it.
and then also, right, like the if you have like segments on, so you were asking about like single band. So like there's a ride that we did that I can talk about later, but it's not all single frequencies, but it's similar frequencies. But this stuff carries so far, right? That we're finding that even on the other side of the ride, because it's, you get on this thing and like you ride around and you feel like it's this giant thing, and really like it's smaller than a supermarket in there, right? So you've got these segments that are like 50 feet apart, interfering with each other. So it's like, lessons learned kind of on the back end of some of that stuff is like either maybe make your segment longer or put a splitter in there or something. So that way it's still the same RF coming out of it, not necessarily interfering. So yeah, there's about every meter you secure it with a clip. If it's like on a crane or something, sometimes you go even more than that because you want to make sure the stuff does not move. And then if you want to kind of protect it, we've seen some people, which this was like pretty cool. We did not come up with this idea, but using like cable tray or something and then kind of mounting it on a standoff inside of that. So that gives it a little bit of protection for people trying to climb over it and stuff. And then in some of the documentation that I looked at, they were saying like use a metal reinforced clip every 10 meters. So like if you have an overhead application where it's like the plastic can deteriorate over time in the environment, you at least kind of prevent it from like falling on somebody or creating a safety hazard. And then here's the big one, right? Is that you have, this is an antenna, and so it receives electrical signals and kind of manipulates them. And if it's not properly like grounded or properly insulated, or if you mount it too close to a bus bar, you can get yourself electrocuted, like I did.
Okay,
But this might
so
be a good time to discuss the bus bar.
well, yeah, then that's what I was going to say for the uneducated. I say uneducated, but for those who aren't familiar with a bus bar is another way to transmit power to typically something that's mobile. So the best example I can think of is think of a trolley. You know, you'll see a trolley and they'll have that boom that sticks out of the top that's running along a cable, and that cable is what's actually supplying the power to move the trolley. That cable is essentially a bus bar because it's got what do you run across mostly like
So
480
it's
bus
usually,
bars?
yes, it's usually 480, but like I mean even stuff like the subways are like 600. But that's nasty stuff and you don't want to touch it or
Yeah,
get
because
close to
typically
it.
if you touch something like that, it won't let you go either. So
Yeah. Or it'll like pop part of your body off if you're lucky enough to survive it.
well, that's always fun, just
But yeah,
have an arm fall off.
and so it's it's usually like three phase, and there's as the vehicle runs around, it's got shoes or brushes that like retain steady contact to it. And in the case where I got zapped, it was actually like an induction type setup. So then you just they have some sort of like coil that sits in that electric field that comes off the bus bar, and it actually gets the power over air. So I can't say the manufacturer's name, but they had some stuff that was mounted a little bit too close. And when we went to like check the seating of the cables, I got a nice little like 110-volt shot from
Ouch.
it. Yeah. Yeah. That was like, I don't tell my wife till I get home. That's also where when we were talking about those electrolyte popsicles with Heath last time. That place didn't have the HVAC set up, and I got one of those, and I still dream about that one to this day. It was good. So another thing, right, is that you have this cable, and so some vendors will recommend, like I know in the ProSoft documentation, they say, hey, you can have up to a meter of overlap, so it's the end of one cable goes past the beginning of the next cable by a meter, so you know that you have an antenna on that segment. Um, but typically, like we will install it with a gap of like a foot or 18 inches or something like that. And then that gives you, if you have to re-terminate it, you've got some distance to do it. And there's usually not any problem like jumping those gaps. I mean, we have some bigger ones. So yeah, so also it can be installed outdoors. It's outdoor rated. It can be UV protected. The end connectors on the end have like rubber gaskets, but you still want to kind of seal that up with some of that butyl or whatever type tape.
I was
You
going to
want to
ask,
weatherproof it.
what do you use to seal the connections, and if you are installing this outside? I know, back in my eProach communications days, we did a lot of outdoor point to point work, and we just used mastic tape,
Yeah, yeah,
that
yeah.
that
That's
rubber vulcanizing tape, and then so once you got it all on there, you give it about a month or so out in the heat, and it all just melts together and becomes this one big blob of
yeah,
rubbery goo that just keeps everything sealed away from the elements.
yeah, and that's fun to like scrape off of yourself after you put it on too.
Oh, it's terrible when you have to go out and change out a part because you have to cut it all free, but it's the price you pay for protecting the gear.
And I mean, it's amazingly and not shockingly, it's easy. It's very easy to terminate. I mean, you just need like a decent hacksaw and some patience, a couple of wrenches, and then there's like a little T tool that kind of scoops out the dielectric and cuts back the outer shield to a certain point, and then you're just putting an end connector on it. And the biggest problem that we see in that is that people don't seat that tool fully, like they don't make sure that everything gets all the way down. But you saw it. You don't have to go super slow, but you get a nice clean cut, and then you can take a little file and clean up the inner conductor, get all the junk out of it, and then just disassemble your part, your end terminator, slide all the stuff onto it, tap it on the end, screw it up, and you're good to go.
So the
Um,
the the end terminator, is that like a just a an attenuation device to really just kind of end the signal
no,
right
it's
there,
it
or
it, it basically just like completes the I don't know if you would call it a circuit in this situation, but it basically like gives you that electrical connection between the outer conductor and their inner conductor. So then, so
Oh,
then,
that makes sense.
so
Okay.
then, yeah. So then from there, you can put your in cable or your impedance load on the end, or you can put like a fixed attenuator. If you're really fancy, you can put like an electrical, like a variable attenuator. But you
So
put all that stuff on there.
so your outer is what actually radiates the RF, but then it hits the terminator and transfers it to the cord to actually transport the data back. Is that how that works? Am I
I'm
thinking
not
about that right?
I'm not an electrical engineer, but yeah, it's probably something like that. But it's similar to like how an antenna would receive it, right? Like it's just a coax cable, and then the perforations allow the electricity to come out of it, or the EM, electromagnetic field. Um,
Interesting.
I'd like to take a moment to thank our sponsor for this episode, Global Process Automation. GPA is an engineering and technology firm based in North Carolina, serving clients in industrial processing and manufacturing, focusing on solutions for industrial automation, operational technology infrastructure, industrial control systems cybersecurity, manufacturing intelligence, and analytics. For over 25 years, their clients have entrusted them with their processes to maximize their company's efficiency and obtain an optimal ROI based upon their assets while protecting their operational technology resources. GPA's mission is to automate, optimize, and secure manufacturing floors everywhere while maintaining their core values to have integrity, to continuously improve, embody their community, remain customer focused, and implement great teamwork. Thanks, and back to our show.
yeah, and so then kind of, just to hit on some of the best practices, right? Like I said, like if you can reach out and touch it, right? Like keep the antenna between 1 inch and 2 meters. Um, if you really need to, you could go a little bit further than that. And then just remember that the signal will degrade the further you get from the cable. And, in just kind of the tech specs, it's about 15 to 17 dB over 100 meters in 2.4, and you get about 27 dB a loss per 100 meters
I was going to ask
at
what's the
5 gig.
loss values, depending on the length of your cable. I mean, what's the longest that you've ever put on a radio?
Well, so the ProSoft guys say 200 meters is what their segments run. And then Siemens,
That's
um,
a long way.
yeah, it's a dang long way. But I mean, they seem to have done it successfully. So I'm not gonna question those guys
Well,
on
those are
that.
those are definitely powerful little radios, that's for sure.
Yeah. Yeah. And I don't know if any of that's like, changes with like the power emission requirements. But typically, like we try to run, a 90-meter segment is a long segment. And then you can kind of job the system by putting a split in it, and then you lose 3 dB, right? Because of coupling loss. But then you can kind of run like 70 in one direction, 70 in the other. So there's ways to do that, but usually it's anywhere from like 50 to 90 meters for a segment for like a longer segment.
So what is I realize you're getting dB loss for the length of the segment, but what kind of gain do you get out of it for it being an antenna?
That's a good question. I've never thought about that. I mean, really, it's like usually we like plug it up, set the power, and then take the measurements off of it. We could look on the
Yeah,
power
that'd be
sheet.
interesting to find out because the gain has to outweigh the loss that you're getting. Otherwise, it wouldn't be worth using, right? Because if you just if it was just nothing but loss the entire way, um, you really wouldn't get much emanating out of the cable. So it's got to be a
Yeah.
fairly high gain antenna.
Well,
Um,
I'm looking at like even on the data sheet, it doesn't say anything about gain in there, which is interesting. From the dB value, antenna gain. Okay, so that's just like power specs. Yeah, so I'll have to look at that. We can follow that up later, and put something in the show notes.
yeah, I think we need to follow up on that as I'm struggling to understand that relationship.
Because it's not listed in the Siemens data sheet at all. But yeah, so another thing is like don't put it in seat it inside, like in an I-beam or like in a channel, because then you get reflective interference, and it really does not like that. And then, pro tip, when you check the alignment using the ridge, like this stuff has a memory, kind of like how if you sloppily like coil up your electrical cord, your extension cords and stuff, like over time they degrade because that stuff kind of builds a memory for like how you roll it up. This stuff comes on a coil, you uncoil it, and it kind of remembers that it wants to go back to that curved state. And so you lay the stuff down your track and then come back 2 weeks later and check the alignment and then mess with it and mess with it. And you probably have to, depending on how it's laid, you probably have to go back, 3 times just to make sure that it stays in place. And then usually we like to do like a torque striping on there. So that way you can, as you're walking along feeling the ridge, but you can also visually see like, has this turned from where it's set?
So you get a visual as well as a
Yeah.
physical
Yeah. So it
while
just
you're
gives
trying to
you,
keep everything lined up.
yeah. Cause the maintenance people that come behind, usually like you hand it off to the customer as far as, cause we're an integrator. We're not a person living in like a plant or as like a steward of a ride or something. So in their PM schedule, you have them like feel the alignment of the ridge and then also like check the torque striping. So then that gives them an easy reference for, hey, somebody came behind here and changed a motor on this vehicle and they decided that this looks like a step and or a handhold, which it's not. And then you get segments that are out of whack. Don't get shocked.
I think we covered that one pretty well.
Yeah. Yeah. So just, obey like the minimum distances from high voltage rails or any of that kind of stuff. Make sure that it's insulated, ground it where appropriate. And then, another one is like you want to keep the antenna, like they call it the remote antenna, but you want to keep the client antenna in line with the central axis of the EM field. So like it emits at like a 45, 50-degree angle kind of out of it as kind of the primary. So you want to stay kind of in the center of that and then also offset your antenna. So instead of putting it perpendicular, the Siemens documentation says like 50 degrees, but you just find kind of an angle on it. It's pretty close because some of that stuff, it's like technically this is the most accurate way to do it, but a lot of this stuff is relatively forgiving. So like you just want to find a sweet spot that you don't have to be super precise on that. It's nice when you can, but so yeah, so torque striping, and then also like this stuff is a passive component, so you can install it in double check, but you can install it in EX zones or like class 1 div 2 and following the same things as like if you did an external antenna AP. So the AP actually has to be out of the EX area.
So that's another kind of new concept, I imagine, for a fair amount of people. What is an EX zone? What are we talking about when we say class 1 div 2? And guys, what we're referring to are essentially explosive zones. So you want to make sure that if you are installing any of this in an area such as that, you don't want to install the radio there. And then you want to make sure you're following all the guidelines for that site. If you're going to have to put this stuff in one of those zones.
Yeah. And then, kind of piggybacking off of that too, then there's also, right, like you want to be mindful of like common outdoor corrosive elements and follow the same like antenna cable, antenna connector sealing practices that you use. So like that butyl tape or things like that. And then this was just like a fun thing that I was thinking of. I've never seen it like directly buried, but I bet you could get away with that. Yeah, you probably get a little bit of a
I don't
tingle
know,
effect.
man. Directly burying an antenna.
Hey, man,
Hey, you know what? Stranger things have happened, right?
I like having a good time. I'd get to run the little trencher.
Oh, you just want to run the ditch witch. That's all.
That's right.
Okay, it's just an excuse to drive heavy equipment that you're not certified to
Yeah,
drive. I'm
that's
down.
right.
Let's do it.
Well, no, then they'll just make you take like the five years of your life OSHA training, so that way you can run this thing for 10 minutes on site. That's usually how it goes. But yeah, and so then typically like we only use this as ISO, and then I've kind of hit on this, but like ProSoft, I think has got some slides that I've seen where they use like two TX chains off the radio, so they have two segments coming off of a radio. And so then that just kind of comes down to how does the vendor that you're using, how does that affect it? When we've had some people direct installations and use two chains on some other radios, and they did not have successful results, because then it's trying to, it might be trying to like transmit on one and then receive on the other, and then you have
So it's
like,
almost trying to do like antenna diversity as opposed to keeping
yeah,
them independent.
yeah. So then that's probably where, like, with that chip level control like ProSoft has, they can probably say, hey, we know that this is on both sides of this, and we're going to handle, we kind of collude with each other to make sure that like something's talking on this and something's talking on
I
this.
need to dig into that paperwork because I've got several ProSoft lab radios, and I'm wondering if they have specific settings for coax antenna deployments.
Yeah. And then here's an interesting thing that we don't see too often, but we've tested it, but you can dual feed a segment of R-Coax. So the ProSoft guys say they do, when I've talked to them, said that they will do a single frequency from both radios on either end and feed it into it. And they kind of they play nice with each other, but in like Siemens documentation, it says make sure that it's separate frequency. So then you want to kind of not overlap channels. So if you're going to do something like that, use like a Uni 1 channel and a Uni 3 channel. So that way you get diversity from it. But we actually just tested this in the office on a segment a month or two ago, and we were getting, we didn't like blast it, but we were getting like 20 megs on two, from both radios. So like an A client and a B client, and we are doing like a 20 meg iPerf over it with no problem.
So you were running two different radios on two different frequencies across the same R-Coax,
Yeah,
correct?
yeah, correct. Two WLANs using the
And
same segment of R-Coax.
you were getting 20 megs worth of throughput there in the lab. What was the latency like on that? Because
I'd
as we
have
know
to,
with this
I'd have
stuff,
to,
it's not so much about your total pipe, but it's about the latency of response time.
I'd have to like actually pull the numbers up, but it wasn't anything like it. It just seemed like normal. It seemed unaffected. Now, when we increased the throughput, we were testing this with some fluid mesh stuff, but when you increase the throughput, like the errors increase. So like at about 25 or 30 dB, that's when it was really like ton of retries. The packet error rate went up. We were getting some link error rates, so like lost packets and stuff. So there's kind of a sweet spot, but I mean, 20 meg for like an industrial vehicle, typically how we would use it is plenty, because a lot of
Yeah, so
times they're,
that should be more than enough. I mean,
yeah,
your typical throughput needed for stuff like that is usually 5 meg or less. But again, it all goes back to the latency on what's the latency through that. But that's
yeah.
interesting if you're able to do that and it's not affecting the latency of the communication. That's pretty impressive.
I have no, I mean, this is like the antenna magic, right? Like I just conceptual, I'm like, how does this electrical signal and this other electrical signal not cancel each other out, even though they're at like slightly different frequencies? And I'm like, I just believe it works. It's,
I think we might have to do a call back to Jim Palmer and get Jim
yeah,
back on the show and see if we can't understand this a little better.
yeah, for sure. And then now I've got kind of in my notes like some fun stuff, and I'm pretty sure that I can say this because we're listed on the ride. But we did the Secret Life of Pets ride in Universal Studios Hollywood.
That's cool. That's a cool ride.
Yeah, I mean, I was like pestering them so hard. I was like, I got to get a sticker for my hard hat, man. It's like the only, like, at some of the other sites, like I couldn't get any, like when I was out at Tesla, for not an RF thing. This was like an RFID project, but yeah. So we got that in and like finished up, and we were supposed to come out and do like the site acceptance testing and like the training stuff for that, like right when the COVID lockdowns happened.
Ooh.
So, and I already hate the sound of my own voice. So I had to do all this like training material, like recorded, to like transmit it and do like a video call like this to like go through it. So that was fun. But yeah, so we won, I forget the exact award, but it was like voted as like one of the best rides. But the interesting thing on this is that, there's like the free ranging trackless vehicles, which are like, I can't say, but like just think about anything you get in it and it just kind of like runs around. It's not tied to like train tracks or like
There's a lot of rides at Disney that are like that, like
uh
Mickey's Runaway Railway,
yeah,
and
some people would say something like that. Yeah. But yeah, so that stuff like is just free ranging, right? And so it it's going to go like an OTA or something. But this is like what's called like an omni mover. And most people look at me like I'm dumb when I say this because it's not a good example, but I think about it like it's basically like if you turned a bike on its side and then you thought about like each vehicle that you could ride on as like a link on the chain. It's just basically like a connected chain that just like rotates around. And so like the park opens, it starts moving, you walk into this little conveyor, you hop on and then ride it around and then you unload. It never stops. And so
all right, there's a lot of rides in general that are similar to that. I know what you're talking
yeah.
about.
But it's so it's interesting because it's like all those vehicles have like a PLC on board and information. And so the trick with this was that it's 500 meters of track or whatever it is, right? Like the whole way down. So we had several segments in there. And then, okay, well, what if this is over a gap or what happens if it's redundant? So then with the fluid mesh stuff, we had a handful of clients that were on board. And then kind of part of the package of that is you distribute these have to be like 10 vehicles apart, however many are on there, right? And so that's, some fun stuff on there too, is like that was like a ring topology on that on the inside. So it's kind of some interesting problems there too. But basically you have these antennas going around these curves and stuff. And we saw all kinds of like weird interference stuff and then trying to figure out, okay, well, like, do we feed the two antenna ports off the radio into a splitter or combiner and then let the radio just be grumpy that it's running SISO? And what we ultimately ended up doing is just putting a terminating resistor on one, disabling the transmit chain, and then letting the first, like letting the primary transmit chain work on this. And so this was really like the first kind of like implementation that we did with like a non-Siemens R-Coax setup.
What did you
But
use for that one? Are you allowed to say?
oh, so it was like the fluid mesh, like it's a
Okay.
fluid mesh mobility application. I mean, it's
Okay.
not there wasn't anything like super secret about it, but I'm pretty sure it was like single band all the way around because they could kind of attach to any segment. And I know in those radios, like there's the ability for them to kind of scan channels and stuff, but we never use that because it adds that latency that we kind of can't tolerate, like on the safety stuff.
Right.
But I mean, that was fun because it was like, okay, we have to like be really mindful of like the MCS sets and reorganizing those and then getting in and changing like the QoS settings and stuff to make sure that that safety traffic is prioritized because it's hitting, it's got controls traffic and stuff going along with it too. So that was fun.
That's pretty awesome.
Oh, another thing on that was so this stuff too is like the nice thing about it is that it's not nice installing it, but like once you get it in, the antenna's like in that machine guarding. So if you basically just kind of imagine like a tunnel of cage that follows around that path of the vehicle, that stuff's kind of inside of that. So it's really fun getting people to like crawl through that and install it. Usually you install it before they put the machine guarding up and then you hope you never have to get in there. And we've seen stuff where it's like, you'll get some of this stuff get damaged by people doing like maintenance construction around it. We had some where there were like nail holes in it and stuff at some other sites. I got a note here about screaming internally, climbing into that stuff, especially as like an RF attenuation vessel such as myself. It's not fun crawling into those kind of small enclosed spaces.
Not at all.
We also found out about like, the vehicle antenna bracket that we put in there, you have to kind of plan this thing's like moving through this set track and everything was supposed to be clear, but there's where the load and unload segments of that, there was like something that wasn't reflected in like the CAD drawing of it, like as you travel through it. So we knocked a couple brackets off by that. That was fun. So yeah, so that's the note in that is like, it was like some aluminum bar stock from the hardware store, a bench vise and a hammer and a step bit. And those things are rocking and rolling to this day.
So really, some kind of key takeaways from all this, right? Things that kind of stand out to me, that when it's your first time working with RCoax, some things to remember. One, make sure you have that standoff when you're mounting the cable, right?
Yeah.
Make sure you're following that ridge line so that you have your antenna oriented properly, right?
Yep.
Beware of any bus bars or other power sources that may be running in a similar course, right?
Yeah, and that's not to say you can't co-locate them there, but you have to respect like the distance away from that it recommends in the documentation.
Understand that most of these deployments are CISO or, single in. So be aware of that so you can truly understand what your throughput values can be and what your latency should look like. And that other than that, when you're looking at the specs of the cable and how the documentation wants you to do everything, you actually have a fair amount more leeway than the documentation would lead you to believe. Does that sound
Yeah,
about right?
yeah, and that's as far as like antenna, distance from the antenna and stuff. But you do want to stay within the best practices of, within the best practices of don't exceed the segment length that is approved by the radio vendor you use. And if there's not one there, then kind of default on the shorter side. And then when you order this stuff, it's like you kind of have to order it a little bit in bulk or whatever, but give yourself a buffer of 10%, just kind of like with Ethernet when you're estimating, but like make the segment if you're going to pre-cut it or whatever, right? Like sometimes you'll say, I know this segment's supposed to be 60 meters, so I'm going to order 65. And so when you put it in there, if you kind of damage it when you're first getting it through there, you can trim some of that off.
And then double check and make sure you are ordering cable attuned to the proper frequency ranges that you
Yeah,
want to use.
absolutely. Yeah, double check the part number because it will not work. And that's kind of going back to that too, is we'll have customers that have the 2.4 systems that want to kind of upgrade it, or they want to swap in a new radio, or they want to switch frequencies because they're getting interference. And they get really upset when they find out that you can't reuse the 2.4 cable. And you have to put all new stuff in.
Well, that's a whole lot to unpack there and digest. Um, as far as coax is concerned for antenna purposes, that's pretty impressive.
Yeah. And
Um,
just got, I'm thinking about this now and I should have put this in notes, but if you want a kind of a high level guess for like how much this stuff costs to install, kind of like generic brackets and standoffs and then the cable, you probably want to budget about $45 per meter for this, and that'd be like the cable and then kind of ancillary components up to like whatever unistrut it's not including like unistrut mounting hardware, but like your threaded screw standoff, M6 washer, and then the clip per meter. So like you're going to have one of those per meter of purchase price. So it's about $30 or $35 for the cable, depending on how things look, and then the additional parts.
so really, we've covered a lot of the basics and the fundamentals of a deployment like this. But I imagine environmental variables will have a lot to do with it when you start talking about the conditions within a mine or the conditions within an airliner or the conditions at any number of different deployment styles. So I'd be interested to hear from others if you have deployed this in some other area and what some of those challenges were that you had uh, with the deployment for radial coax. Um, you can hit Jeremy or I at online at our email addresses, Jeremy at theindustrialwifishop.com or Scott at theindustrialwifishop.com. So what else you got going on these days? You got any new toys or tools you're testing out and playing with?
Well, I do want to start off by saying if you're in Hollywood, there's a really good Thai restaurant nearby. I don't know the name of it, but it has a golf ball for a sink thing to turn the water on and off, so it's good. And then there's also a place called Poquito Mas that's like right near one of the exits, and it is fire. It's really good. But new toys or tools. I did that very poorly organized documentation roundtable that you graciously joined the other day. And so kind of on my list of things that I want to look into. Some people mentioned Netbox, which is a kind of like a source of truth for like your network documents. And then Heath mentioned that he uses this thing called Termius for his team, and that's kind of a like an SSH client that'll, and you can actually like use that to allow remote access to an SSH session that you have established locally. So that seems like something that we're going to probably check into because sometimes it's easier to just log in remotely than to hop on a plane. And then another fun kind of thing that came out of that was like just something that we don't think about a lot, but it's like, is your documentation like colorblind friendly, right? Because some people will not see what you put on there if it's just plain colors, so like hue or just distributing it in black and white.
Yeah, I'm
Snap.
guilty of doing a lot of my documentation specifically with colors for differentiation because it makes it so much easier, than trying to figure out ways to differentiate on black and white.
Yeah, and so and usually like if I'm doing like circles for predictive RF coverage, I'll put the I'll put the text on there too, so that when you look at it, you know kind of what it references to, just in case. And then my all time love, I found out a new trick for Draw.io or diagrams.net. That when you export the PNG, you can also like embed the HTML in it. So you could send somebody a picture and then they could drop that into Draw.io and edit it themselves. So that was
Oh, that's cool.
yeah, that stuff was pretty nifty. Yeah, I mean there's like a ton of other stuff, but those are some like really good suggestions and tools that I'm looking
Well, I
at.
thought the documentation roundtable went well. I think we need to repeat that here relatively soon, and get some more input. I think that'll be a good time.
Yeah, we're gonna hustle some vendors and giving us some demonstrations. What about you? You playing with anything fun?
Man, currently I got two things on my docket as I have time. One is those set of radios from R3
Hmm.
that use that wireless token ring protocol behind it, and then further work with my Cyberscope Air because this thing has got so many things it can do, and I have the one main thing I have yet to really put through its paces is to do a full passive survey with just it, and not use any other tools to see how I'm able to integrate that into my reporting and whatnot. Especially with the fact that now that Hamina is integrating with the results that you can get in Link Live, I'm really interested to see how that will go. So my next project that I have to do any passive survey with, I'm going to do it completely with my Cyberscope, so I'm not carrying anything else around. The battery life on this thing is incredible, and then I want to see what I can do with all of the information after the fact. There's a ton of analytics in Link Live itself, but I want to export that over into Hamina and see what that's going to give me, because I know I can
Yeah.
already download it and import it into my air magnet. And I'm used to pulling stuff out of that for reports. But I want to see what that integration with Hamina is gonna do.
Yeah.
That's kind of in on my burner space outside of work and life.
Yeah, the more I've seen you talk about that tool, the more I think that that's like that's probably going to be like a recommended tool for us to tell for like some of the entertainment customers like, hey, if you, because it's got the built-in spec A
Yeah, and that's a
and
huge bonus between the spec and its survey utility, let alone all of its just standard Wi-Fi scanners and everything like that that's built in, the ability to do PCAPs on it.
yeah,
It is an Android-based device, and there is a NetLI kind of app store that you can go to and download apps to it. And so there's an app called Analyty. And if you get the pro version of Analyty, which I want to say is like 60-80 bucks, you can also read PCAPs directly on the device and not have to
nice.
export it. So
Yeah.
let alone it's got that whole other scripting tool built into it, to run a ton of other network discovery scripts and everything like that on it. And so if you get connected to a network with it, you can run a ton of different security scans and whatnot, and it comes pre-built with like 6 or 8 pre-built scripts that you can run for device scanning and things like that. But you can sit there and do all kinds of custom scripting if you're a scripter. I am not, so I might see what I can get some of my coworkers to drum up, and maybe I can just throw them some beer and they'll hook a brother up. But
Yeah. Well, last time I wrote
it's
some
pretty
code,
impressive.
the last time I wrote some code, I used the indexing variable I outside of a for loop, and my colleague made fun of me incessantly for like 2 months. It's like, dude, I don't know. It's
So I
pretty
don't
funny.
know how many people out there have used Nmap, but all the different crazy things you can do with Nmap, you can do with the Cyberscope because Nmap is in the device.
Nice. So with that PCAP, I would be curious if you can use like dissectors on board, like if you could load like a Lua in on that, because I imagine like the R3 stuff, and I know like the fluidity stuff is a proprietary format, but like if you can capture that PCAP and kind of break it down with those dissectors. So that's something I'm gonna offline, I'm gonna pepper you about. I just made a note for
Yeah,
that.
I gotta hit up the NetAlly guys and see if you can side load apps into this,
Mhm.
like most other Android devices. Because that you're absolutely right. That would be a very cool feature to have.
And then you need to find out if you can run Doom on it,
Oh,
because that's what all the cool kids do.
that's true. And it is touchscreen, so
And did I tell you this is not like a NetAlly comment, but did I tell you about that NW Towers antenna that we've got some on the way to check out? It's they primarily use them in mining, but it's like a 60-degree vertical beam width omni. Um, and so we had like a crane application we were looking at where one of the radios needs to be on the ground, one of them needs to be high up, and they get 20, it gets like 20, 30 feet from the end of the rail where we'd put the access point, but it also goes about 500 feet out.
mhm.
So I'm kind of excited to check that out.
Yeah, that'll be interesting. Yeah, crane work can definitely be a challenge because of the changing distances on
Yeah,
what you're
and
doing.
that's also a slip ring a slip ring bypass desire too.
Yeah.
So they want to get rid of that.
Yeah, it's very similar out in pulp and paper and wood yards because you have stacker reclaimers that constantly move back and forth on these tracks. So sometimes it's closer to the AP, sometimes it's way far away from the AP, and you got to be able to handle both.
Yeah, and then I just showed you that those clear Exceltex antennas that Connor made, Connor Burt from
Those are pretty
Exceltex.
cool, man.
That was cool because it's like, you look at it and you're like, what's inside of there? Um, so maybe we can talk some customers into, like put those in an Apple store or something. They look pretty slick.
So, you know what? Let's end the show with a question, and you got a question from one of your coworkers. So let's put this question out there, and if anybody has any feedback, please hit us up at either Scott or Jeremy at the Industrial Wi-Fi Shop.
Yeah. So, well, the question for the listeners is, how would you apply RCoax at your site? Are there any unique or vanilla applications that you're thinking of? So, Scott or Jeremy at the industrialwifi shop.com, reach out to us. And then the question my colleague had, because he's kind of newer, but from a kind of a deep approach, what's the difference in like fluidity, which is the Cisco ultra reliable wireless backhaul curb, protocol, that MPLS protocol versus like a traditional 802.11 setup for communications. And I think that might be a good topic for like a deep dive on like fluid mesh curb
I
down the
think that's
road.
a great idea, and I think we'll do that soon. I think a deep dive on curb versus standard 802.11 is an excellent idea.
And then we need to get Jim back in. That would
Yeah,
be,
we absolutely we need to get Jim Palmer back on this show. See if I can con him into it. Send him
let's
some
find,
Oreos.
yeah, that's right.
Oreos
I
and
was
bourbon, just
I was
not
talking to him
together.
about I messaged him on LinkedIn, like replied to a post and said that or it might have been Slack, but said that they need to do like an Oreo style auction with some of those, like that gym with the shiny helmet head, so it's like you're bidding on Oreos. Anyway.
Well, thanks everybody for dropping by. And we hope to have you back here again soon to the Industrial Wi-Fi Shop. Have a good one, Jeremy. I'll talk to you later.
Later.
Thanks for listening, everybody, and we hope you join us on our next episode of the Industrial Wi-Fi Shop.